My name is Morten and you are watching Frost Astrophotography. Welcome to PixInsight tutorial part 3, Linear Image Processing. Today we're continuing on our PixInsight tutorials and we're going to start with some processing. Now, if you haven't seen my previous videos about calibrating and stacking your images, please consider doing that before jumping into this section. In this tutorial, we're going to do some processing of a mono picture captured by my ZWO ASI294MM Pro. If you have a one-shot color camera, the processing steps will be slightly different, but some of the processes will of course be used in both cases. The processing of a mono picture is done in two major steps. First you have the linear phase and then you have the non-linear phase. And in this first video we're starting with the linear phase. First we're going to open up our process icons. I have explained this step in an earlier video. You right click process icons, load process icons, and I have one called mono. Now this will open up all the processes, or not exactly all, but the most frequent that I use in my processing. I can also open up my screen transfer function window because I will be using that a lot. The first thing that we are going to do is open up our 3 calibrated and integrated light frames for the different filters. Here I have my HA and my O3 and my S2. Now the first step is to examine your light frames. As you can see in this one, we have some stacking artifacts at the bottom and we don't want to keep that. So I want to crop that out. But what's important here is that you have to crop all 3 frames exactly the same, because the stars have been aligned right now against a single HA reference, so the stars are aligned. But if I crop these in different ways, the stars will not be aligned later on when we integrate. So I'm opening my dynamic crop tool. You can also open it through processes, of course. I will drag the line here in towards the center, just removing the outer edges. Before I do anything here, I'm going to save an instance of the settings in this dynamic crop by dragging this triangle onto the desktop, and that will keep all of the settings here exactly the same. Now I can close that and I can open this window and I can drag an instance of this to my S2, cropping it exactly the same. I can drag one to my HA, cropping it exactly the same. And then I can crop my O3, then close this one. If I adjust the window, I will have 3 identical frames, or identically cropped frames, I should say. And I really want to save files as I go along. So I made a directory called processing, and then I have linear processing, and then I'm going to save an HA DC, that stands for dynamic crop. I'm going to do the same for O3. You can of course skip this step if you don't want to save a file after each time. But I think it's good to have saved files for each step. The next step is that you check to see your rotation. I have already stacked my images and aligned the stars with a reference frame with the rotation that I want. But if you don't, you can always do it manually right now by selecting an image, go to the image menu, geometry, and then rotate it 180 degrees or whatever you need. If you do use that, please make sure that you have the same rotation on all 3 of your frames. Next step is to remove as much of the background as possible without removing any data that we want to keep. There are 2 ways. There's one process called dynamic background extraction, and there's one called automatic background extractor. Now I have some varying results with the 2. Seems like the automatic background extractor sometimes is very good, even better than the dynamic. And vice versa, sometimes the automatic background extractor is not very good at all. So the automatic is of course a much faster tool. Let me just open it and use it for you to see. You can use the default settings and just apply it with the triangle. And keep in mind that after you have made any adjustments to the background, you will need to reset your screen transfer function and stretch the image again. And as you can see, this result is not very good at all. We have basically not removed any background whatsoever, except for small parts. So I will not use the automatic background extractor for this image and this frame. And if I don't use it on this frame, I will not use it on the other 2. I will use the same process. So I'm going to undo this. And I'm going to apply a new screen transfer function. There we go. Select the first image that you want to process and then open the dynamic background extraction. Select the background and you can also zoom in to make sure that you don't accidentally select a star, for example. Now this process can be a bit tedious, but it's always good to be thorough here. You can also move them around, as you can see. You can also use the tool to make a grid if you want to, but I feel that it is quite sufficient to manually place. Now this procedure can be repeated several times if you feel like there's not enough background extracted in the first run. When you feel like you're finished with your selecting of the background, you simply execute the process will actually show you the extracted background that you can stretch, and it will create a new image with the background extracted, and you can stretch that with the screen transfer function. There's already a big difference between the two. You can see on the left without dynamic background distraction and on the right with. But I do want to extract some more, so I will open up a new instance. I will zoom in here. I will place some new, just to remove a bit more of the background here. So I'm finished with the second round of selecting my background, and I'm going to execute this one more time. Same procedure as last time. The background has been extracted and I have a new image. Let me cancel that and let's compare. So this is the first round and this is the second round, and I'm a little bit happier with the second one. Now it's removed a bit more of the background. So I think I'll save that. I remove this one and I will save this as DCDBE for dynamic background extracted. Now you do the same procedure for the S2 and the O3, and you might ask yourself, can I do the way we did with the dynamic crop? Can I save a dynamic background distraction and use it? Yes, you can. If you use the same settings like we did on HA, on, for example, the S2 here, we zoom in, you will see that we don't actually capture the same amount of stars, and here, for example, this selected point is right over a star, and we don't want to have that, and we might have more points over stars. So I would not suggest to save and use the same settings, and that means you have to do it manually for each of the 3 frames. And when you're finished with selecting the background, you execute it. You can close the background file and stretch the extracted. And let's take a look. Before on the left and after on the right. You don't see that big of a difference on this file, but just slightly. And you can do this one more time as well if you feel like it. So the original and the background extracted. I'm going to close the original one and I'm going to save this as dynamic crop, dynamic background extraction. Moving on to the final frame. And finally, the final image, execute. We can discard the background and we can stretch the new image. And I don't think I will do a second round on this one because I don't think it will do anything. So I'm going to take that image, save it, DBE. The next step is to make all 3 light frames for the different filters the same contrast. This is important for steps later on in this process, and there is a process in PixInsight to help you with this. You could also use curves transformation, but that is much more tedious and harder, I would say. Open up the process called linear fit and then select a reference image, and I would suggest using the HA as your reference. And then you just simply execute that on your O3. And execute it on your S2. Now when linear fit is completed, you will have to remove and re-stretch the images. So we'll start with S2, remove the stretch, and do a new screen transfer function. And also for the O3, and you don't have to do anything for the HA. Now all of these 3 images are matched in terms of contrast. This looks a bit darker, but that is just because the signal is much stronger for the HA. So I will save that as linear fit. I will also select the identifier, and I will save the O3, and I will also change the identifier and the S2. Now, like I said in the beginning, you don't actually have to save images after each step or change the identifier, but I find it practical, and I can always load up a previous image and continue on that if I want to, but you could of course also use the undo. But having an image saved for each step is good if something should happen to your computer, a power outage or something like that. Next step is to apply some slight sharpening and to reduce the stars just a little bit. Don't want to overdo the sharpening at this stage of the processing, because we're going to do much more of that later on. The process we're going to use today is called deconvolution, and for that we need something that we call a PSF. A PSF is basically a model of the average looking star in your image. Now you can manually generate this PSF if you want to, but I prefer to use a script called ECDcon. ECDcon is included in the EC processing suite, and you can download that if you Google the EC processing suite and download it. You can install it using PixInsight resources. You can install this by going to resources and updates, manage repositories, and here you can add a link to the repository that you want, and then click OK. Start the ECDcon. Now, I'm not actually going to do some deconvolution within the script. I'm just going to use it to create the PSF that we need. So what you do is that you click on your HA frame and you click on the deconvolution tab and then generate PSF. Now I've already prepared this because it takes a few moments. When it's finished, you just switch over to your O3 and then S2 and repeat the steps, and then you will have 3 new images on your workspace, and that is basically the PSF files for each of your frame that you can use later on. Inside deconvolution, we also have something called a deringing, and that is basically how you control how much deconvolution or sharpening to add to the stars. And this can also reduce the stars a bit. That is actually what we need or want to do. You can use a local deringing support, and that is basically a star mask. And in order to do a star mask, you can use either the process star mask, or you can use StarNet. Now StarMask is much faster, but it will not do as good of a job as StarNet. But StarNet will take much longer to run. I prefer to use StarNet, and I've actually installed StarNet version 2 that you can download and follow the instructions in the README file in order to install it. You basically install it by using modules and install modules after you have copied the files inside of your bin or library folder, depending on if you have a Macintosh or PC. I don't really want to do a starless version of the image right now, but since I have to do that to create a star mask, I will make a copy of this file. As you can see, I've actually already done my HA and my O3, so what's left is my S2. Since this file is in linear mode, if you have used StarNet before, the first version only worked on nonlinear images, but in version 2 you can use it on linear data as well, as long as you check linear data. And then drag your triangle and execute it. It has completed. Now we have a star mask, and we will change the identifier according to the standard S2 star mask and save that with the other star masks. And here we also have the starless version of the S2, but we don't want to keep that right now, so we just delete it. And we can close the StarNet process. So now we are prepared to do deconvolution. We have our 3 light frames. We have a PSF file for each light frame, and we have a star mask for each light frame. In the deconvolution process, under external PSF, click on select PSF image and then choose the H-alpha PSF, and under deringing, select that. If it's not selected, select local deringing and then select the HA star mask. Now I don't change any algorithms or iterations, but the setting that you want to adjust is global dark. This is where you can control the strength of the deconvolution effect. Since we don't want to wait for the entire image to be processed, we want to create a couple of previews that will allow us to adjust the settings to something that we like. So I'm going to click the preview here. I'm going to select an area with some interesting details. I'm also going to select some stars in a lighter area, and I'm going to select some stars in a darker area, and this will allow us to adjust the settings. I'm going to start with preview 1, or perhaps preview 3, I would say. Now you can start with whatever preview you would like, but let's just try and apply it to the darker area at 0.0320. And as you can see, it's not so good. You can swap before and after using Ctrl+Shift+Z. And I think we're going to go somewhere down to 0.00, maybe 80. And apply that. And just a subtle sharpening of the stars here. I think I want something around 0090. Let's look at preview number 2. And preview number 1. Yeah, I think I like that. So we're going to go back to the main image. We're going to delete our previews and we're going to apply the deconvolution to the entire image. And now that is completed. If I undo it and redo it, yeah, you can just see a subtle sharpening of the entire image, but nothing you really notice. Moving on to my 03, I'll do the same. I'll make some preview windows here. I think we're probably going to use about the same settings. I'm going to swap out the PSF for the 03 and also the star mask for 03. I'm going to select my preview 1 and apply it. Just a subtle change. And the same here. Yeah, I think I'm happy with that. Remove the previews and apply it to the entire image. And that's completed. Moving on to the final image. Just making some preview windows here. Changing the PSF to the S2 and changing the star mask to S2. Preview 1, apply. Just a subtle change. And the same here. Yeah, I think I go with that. Remove the previews and run it on the entire image. There we go. Now I can close deconvolution. I think it's good to save these files just in case, but we're actually going to be making new star masks later on in this process. Now I'm going to save this as deconvolution. I'm also going to change the image identifier so that I know that I would run a deconvolution on it. And the last one. Now, like I said, this is optional, of course. Next step, we are going to remove some noise in the image. And for that, we're going to use the multiscale linear transformation. And before we can do that, we need to make a copy of each of the light frames. And we're going to stretch that copy, and then we're going to use it as a mask so that we don't apply the noise reduction to everything. We just want to apply the noise reduction to the background. So starting with HA, making a copy, the same for the O3 and the same for the S2. Now I'm going to minimize these while we are working. Now in order to use these, since they are in a linear state right now, if we remove the screen transfer function, you will see that. We're going to have to permanently stretch them. But I don't want to do that manually because that will take some time. So I will do that using the screen transfer functions and the histogram transformation. So I will open the histogram transformation. I'm going to reset that just to be sure. I'm going to start with HA. I'm going to apply the auto stretch, and then I'm going to drag the auto stretch settings by taking this triangle, dragging it over to the histogram window and dropping it on the lower gray bar. That will actually copy the settings. And then I'm going to take the triangle and drop it on the HA light frame, and that will apply a permanent stretch. Now it becomes completely white. That's because I am permanently stretching it and have the auto stretch on. If I reset the auto stretch, I get the image permanently stretch. Minimize that, place it up here for now. I'm going to do the same for the O3. First I'm going to reset both windows. I'm going to stretch it, auto stretch, copy the settings and apply it to the image and remove the auto stretch. Reset that, auto stretch, copy, apply, reset. Now I'm going to open my linear HA and my non-linear HA. I'm going to apply the right one as a mask on the left one. So I'll grab this and drag it over here and drop it. Now you can see that there's a mask applied, and everything that is red is protected in this image. But since I don't want to protect the background, I'm going to go up to mask and invert mask. Now you can see that I'm protecting the nebulosity and the stars. In order for me to see what I'm doing, I don't want the mask to be visible. So I'll go up to mask and I click on show mask. And now it will disappear. But you still see that there's a mask active by the color here. Then we will open the multi-scale linear transform. Now, if you have never used it before, it will be in the default settings. I'm just gonna quickly go through it because these are the settings that I've tested earlier, and you can also find a lot of videos about this. I'm going to use the starlet transform algorithm and the dyadic layers, and then I want to have 4 layers. Each layer have a noise reduction setting, starting with the first layer, a settings of 3 and an amount of 0.5 and iterations 3. The second I have 2, 0.5, 2, and the third one 0.5, 2, and the last one 0.5, 0.5, and 1. All of the other settings are completely default on this one. Before we run it on the main image, you want to remove the auto stretch. So the image looks like this. And then you actually just take this and drag the triangle over here to apply it. And after it has completed, you can reapply the auto stretch. And hopefully we'll have some reduction. Let me show you. We can zoom in here. The top corner, I'm going to undo. And you can see all the grain. I'm going to redo it. And you can see it has been smoothed out successfully. So now that's completed, I can remove the mask. I can save that. MLT. And the identifier. And minimize it. I'll take my O3. I'll open up my stretched clone here, apply that as a mask. I'm going to invert it and remove, not remove, but don't show it. And remove the auto stretch and then apply the MLT. I'm going to reapply the MLT. I'm going to zoom in here and see if we've had some success. This one was a bit noisier than before, but we have removed some of the noise anyway. Yeah. We'll see how that works out later in processing. Going to save that. And also change the identifier. And the final one. Apply that. Mask. Invert. Show off. Remove the stretch and apply the noise reduction. And let's reapply that and remove the mask. Check to see what happened. Remove, undo it. Yeah, a lot more grain. Yes. Save as MLT and also change the image identifier. I forgot to remove the mask on this one. Didn't on this. Now I can delete these 3 because I've already used them. And I don't want to save it. I can also close that one. The final step in my processing workflow for the linear phase is to actually permanently stretch the images, making them non-linear. Now there are a few ways to do this. You can manually stretch them using the histogram transformation that I will show you in a minute. You can also copy the auto stretch settings from the screen transfer function and apply those like I did with the cloned masks earlier. A third way, and there's probably more ways as well, is to use a popular script that you can download called Generalized Hyperbolic Stretch. I've only tested this once, and I'm not going to cover that in my workflow right now. But if you Google for this, you can find a JavaScript to download, and then you can install it in PixInsight and try it out. I'm actually going to use the histogram transformation and manually stretch the image. So I will start with selecting the HA. Then I'm going to remove the auto stretch. And then I'm going to start stretching this image. And you do that by dragging this middle lever here to the left. Apply it with the box square, or just drag the triangle in there. And when you have done that one time, you will reset the tool. You can see that the image or the graph, the peak of the histogram is being visible. You drag that over to the left one more time. You reset the tool. Now you want to be careful here because you don't want to clip any data whatsoever. So when dragging this over, don't go over the graph, I would say. Something like that. You can also adjust the left here to reset the black points. But in the same manner, be careful so you don't clip any of the data. Something like that maybe. Next, it's time for the O3. Remove the auto stretch and select the correct image and start by gently stretching it and resetting the tool as you go along. and adjust the black point. Be careful not to clip any of the data in there. Something like this. And the last image, the S2. First stretch, second stretch. I think this is the most faint of the data. Adjusting the black points over until you can see here that you don't clip any. If you're up here, you see you clip a lot of data. Something like that, and then drag that over to reveal some more information. Okay, now we have 3 stretched images. Now I'm just going to set the identifier histogram transformation and save that as histogram transformation. And the last one. And now we have finished the linear processing of this workflow for an monochrome SHO image. And in the next episode, we will start to do some non-linear processing, and we will also combine these 3 images into one with the SHO palette to have these nice gold and blue colors that we are used to seeing. Thank you so much for watching this video and my PixInsight tutorial series. If you like this video, please consider subscribing to my channel, and if you have any requests on upcoming content, please leave a comment. Until the next time, I wish you have some clear skies.